Hello guys, myself I'm Karthik Tenity. I'm going to explain from now onwards like the supervised RE kernel methods which are used for relational extraction, which involves identifying relationships between entities and in text, can be done using a set of machine learning techniques called kernel methods. These methods work by measuring how similar different pieces of data are to each other. While kernel methods are often used to tasks like classification and prediction, they can also helpful in relational extraction. And these are different types of kernels, but two of the most common ones are the linear kernel and the RBF. RBF is radial basis function kernel. This linear kernel looks at how closely two data points match be calculating to their dot product, while the RBF kernel measures their similarity using the distance between them in space, especially this Euclidean distance. Although kernel methods can be very effective, they can also be quite demanding in terms of computation and also can be sensitive to choice of kernel. This means that picking the right kernel for a given task is crucial for achieving good results. And moving on to the other slide, which are like rules based on RE. The rules based on RE is like relation extraction uses predefined linguistic patterns and rules to identify relationships between entities in text. And also it relies on synthetic and semiotic structures such as dependency, pairing, and regular expression to detect these relationships. While this method is effective for recognizing basic relationships, it has limited flexibility, and also it struggles and relationship that it has not been explicitly programmed to recognize it. In simple terms, rule-based extraction works well for well-defined, straightforward relationship, and however, its limitations lies in only being able to capture predefined relationship types, leaving out more complex or previously unseen relationships. And the rule based are like it has some group of like flowchart which depends on the categories: biomedical text documents and pre-processing and relevant versus irrelevant information, and relation extractions and extraction relation. These are upcoming topics which we're going to see on the upcoming slides. The distantly supervised RE is like the technique where the goal is to identify the underlying concept in that the words in a passage, typically a sentence, or trying to express, to reduce the need of human and annotations in relation extraction task. Distantly supervised approach has been developed. However, these approaches often challenges with lower performance. Despite this, supervision is commonly used in building knowledge and also based on because it's highly efficient. The downside is the automatical generated data can be of low quality, often containing many irrelevant of or incorrect words.
Kumar Reddy Konde. Now I am explaining about distantly supervised RA schema. This picture shows about the process begin with the structured knowledge based on the unstructured text data, whereas come to distantly supervised RE schema. Different types of text required different models for accurate relation extraction. The output is structured representation of relationship useful for applications like knowledge graphs, information retrieval, and AI-driven discussion making, etc. This approach is widely used for NLP, is nothing but natural language processing, a knowledge graph, and construction and automated information extraction. Whereas come to next slide, that is unsupervised RE. If we see here in unsupervised RE is like unsupervised RE relationship extraction is a way for computers to figure out how different things in a sentence are related without needing human label examples to learn from. It's useful when there is no pre-made dataset available or when we don't even know what kind of relationship we are looking for. when exploring new information. There are two main approaches generative methods try to create patterns from scratch. Discriminative methods rely on recognizing patterns in the way words appear in the sentence. Both approach look at the raw text and use either predefined rules or sentence structure to identify relationship between entities. Whereas come to next slide, sorry, unsupervised. Whereas come to unsupervised RE analogy, there are some steps like pre-processing and relation extraction and relation clustering. Whereas come to processing, processing is nothing but this step prepares the way for raw data relation extraction, and this process includes document retrieval, like a collection of relevant data from web sources based on the specific topics, conversion transforms the relevant documents into the plain text format. Where and Next is like a sentence processing. Sentence processing is nothing but detects sentence boundaries, like recognize name entities, like that is any like persons, organizations, or locations. And next is resolves conformations when different words refers to the same entity. Next is language filtering. Language filtering is nothing but ensuring only relevant text data is used for the further processing. And next is second one, relation extraction. Relation extraction is nothing but the step identifies relationship between the entity in the text. Relevant sentences are filtered from the pre-processed document. That is like a synthetic and type dependency tracing analyzes the sentence structure and extract meaningful relationships. And relations are stored as skeletos based structures and subject object verb relations in a table. Next is relation clustering. This step groups similar relationships together, like a relation filtering removes redundant or irrelevant relationships. Clustering groups similar extraction relationships into the meaningful categories. And final output is like a table of cluster relations which can be used for knowledge discovery or further analysis. The summary of this unsupervised RE analogy is like nothing but the diagram illustrate that how raw text data is processed, analyzed, and structured into the meaningful relationships without required labeled training data. It highlights the automation of relationships extraction, making it useful for domains where the labeled datasets are available. The conclusion of our topic is what our friend Karthik and the Shiva is explained that the relationship extraction techniques offer various approaches for uncovering connections between the entities without textual data. These methods ranges from supervised learning, leverage annotated training data, to unsupervised and rule-based approaches, which rely on the pattern